Really?
So a common misconception, or we call it an alternative conception, that many people carry into adulthood is around this idea of why the thermal energy or the temperature of the equator is hotter than the poles. And the spontaneous answer to that question that many people give is that the equator is closer to the sun. And while that's actually true, generally speaking, the situation is that the Earth is so enormously far from the sun that the distance between the equator and the pole, this distance here, is tiny by comparison. So that's not really the reason why. So I've tried to draw a picture here that sort of illustrates it better. And if we think about, like, energy from the sun comes right across this zone, but if we think about just packages of energy for the time being, then the energy that strikes the Earth near the equator strikes it more or less perpendicular, and so that energy, that package of energy, is concentrated over a small area. But if we think about the same size amount of energy striking up near the poles, what happens is it strikes obliquely, that means on an angle, and the area that it covers is quite a lot larger, and so the same amount of energy is dissipated over a larger area. And so there's not as much heating nearer to the poles as there is down nearer to the equator. And that's the real reason. Now, the reason I'm talking about this in a way is that one of the ideas in the curriculum is about thermal and light energy from the sun being transferred to the Earth, and that this is one of the main mechanisms of having energy on Earth. So in the sense, Earth's mostly a closed system, but in this sense it's an open system. So a lot of our energy for many of our biological systems and some of our biogeochemical cycling systems, the energy for those things come from the sun.